Good morning, everybody, or good afternoon or good evening, depending on your part of the world. This is Nathan Miller. I'm the CEO of Proving Ground, and I think we are ready to get started here on our topic for today. A couple of logistical items before we get started. This session will be recorded. And as an attendee, since you signed up, you'll get access to the recording afterwards. It'll be published to YouTube. Feel free to share it around. We will also be using a data set as part of this session, and that will be made available as well after the session. So if you're interested in playing around with some of the files and techniques that we'll be showing, you will certainly have access to all of that in the aftermath of the session. But we have a lot of material to cover today. So without further ado, we can get going here. For a little bit of context, this is a webinar that is hosted by Proving Ground. We are a digital design agency based primarily in the Midwest region of the United States. We're all working remotely from each other. We're kind of a lean team that's very much focused on this idea of leveraging data and technology to improve the built environment. And we have a handful of products that support that mission, and we also provide a variety of different services to help architecture, engineering, and construction organizations and owner-operator organizations leverage their data and technology better. The topic for today is focused on Conveyor. Conveyor is one of our products that introduces a number of simple, powerful, and streamlined workflows for integrating Revit and Rhino together in a manner that allows for data exchange and geometry exchange to exist between these platforms. One of the major premises of Conveyor is the idea that we wanted to create a very user-friendly toolkit that can scale to a variety of users that may not have expertise in computational design or coding or sophisticated data management. We wanted to create a set of tools that could be used out of the box to facilitate these workflows. And as we know, as industry experts in the area of technology, Revit is obviously a very widely used building information modeling tool, especially in North America, where we primarily do business. And Rhino has grown to be a very widely used design tool and a very flexible modeling environment. And so it's been kind of I guess a mission or a trajectory that we've been following now for over a decade, figuring out the best ways of integrating these things together. To kind of set the lay of the land here, there are going to be two of us talking in today's webinar. My name is Nate Miller. I'm the founder and CEO of Proving Ground and have developed a lot of the code and the inner workings behind Conveyor. And I'm also joined by Nicole Mater, who is our newly minted director of product, joined our team just in the last just about a month exactly, maybe a little over a month. And she has been doing a deep dive into Conveyor and to start out, and she has built out the data set that we'll be reviewing today. So you'll be hearing from her as we move along here. So I wanted to kind of set the stage first with just the premise of integration and why this approach for combining tools together is so important. We have been a part of a number of highly complex building projects over the years as consultants, and over time we have been building out tools that help architects and engineers project manage their digital workflow. And two projects in particular really, I think, set the stage for a lot of the workflows we'll be talking about today. One is the Lucas Museum of Narrative Art being built in Los Angeles. It's a beautiful project by MAD. Stantec is the executive architect, and we helped that group basically stitch together a number of digital assets, Rhino and Revit and Maya being the three major ones when it came to coordinating the design with building information modeling and documentation. Similar on the project here, the Gilder Center for Science Education and Innovation by Studio Gang, they had developed a really beautiful interior idea and using powerful tools such as subdivision modeling, mesh development. And there was a need to really think about different ways of integrating this novel and rather complex geometry with Revit. So the need was really born out of these real world project experiences. And as we kind of developed the toolkit through these project experiences and through the various kind of industry insight that we've had, we've come up with a toolkit that supports a variety of different integration opportunities. One is this idea of being able to import external geometry in a very kind of seamless and smooth way into Revit. So if you have a Rhino file that's sitting outside of Revit and you've received it from a collaborator, you need to have a pathway for getting it into Revit to continue your coordination. And then in the last, I would say, year and a half, the Rhino-inside Revit paradigm has been introduced, which allows Rhino to and Grasshopper to run inside of other applications. And so we've extended Conveyor to leverage this capability, and we've introduced new user interfaces that allow for a paradigm where you're able to click your Rhino object and say send to Revit, or click a Revit object and say send to Rhino. It's very kind of built around this idea that if you can click on an object, if you can create an object and you can click on it, we want Conveyor to be such that it allows for that data to be transferred between applications, and that you shouldn't necessarily need to know Grasshopper or kind of really other kind of complicated paradigms to really take advantage of your data in your geometry in this way. So today's topic is going to be based around maybe some tutorials on how Conveyor works, but also we'll be covering a variety of best practices for managing data between these environments. Every project has its own kind of complex and unique requirements. And you might encounter an element type that could be transferred over into Revit in a certain way. There might be some best practices in terms of model setup. How do you handle multiple collaborators operating on the same set of Rhino models in adjacent to Revit? How do you kind of determine what the best form of geometry an object should have and take in order to kind of transfer over into Revit seamlessly? We're going to try to answer those questions as we go through this data set. And because we're kind of in the middle of basketball season here with March Madness, we thought an arena-based data set would be a lot of fun to do. Stadiums are interesting. We recognize that not everyone does stadiums. Are very kind of, in some ways a niche building type. But they offer kind of, a fun aspect to them. We can kind of explore geometry that is more easily modeled in places like Rhino and transfer them over to Revit. There's geometric complexity. There's kind of novelty around certain element types and certain problems. So we thought this would make kind of a fun data set to explore. They're also quite big projects oftentimes. This is the data set here is based on a 10,000 seat arena. And so, this idea that we have a real world, kind of more of a real world complex data set to work with here, we thought would be important for the workshop, this workshop here. So we're going to be dividing this session up into a couple of components. I'm going to lead right into a general model setup set of recommendations, and we'll explore relationships between Revit models and Rhino models. We'll talk about basic stuff like origin point modeling and scaling of model assets. Then we'll dive into converting some objects over, such as the stadium bowl and seating, and some specialty wall components called vomitories in the stadium world. And then we'll talk about tracking imports. And then we're going to transition to getting into other kinds of element types, including managing of component families, blocks in the form of seats, and some different options that Conveyor opens up in this space. We'll also be converting structural objects and some complex exterior facade objects. So we're going to cover a wide range of things. We're going to do so in a breakneck speed here. We're going to kind of try to get through all of this in an hour. Which I think is also something that we want to highlight, is like by calibrating your workflow in just the right way, you can be extremely efficient with how you manage this information. So I'm going to get right into it. We're going to get out of PowerPoint and kind of get into a tour of the model. And what I want to say as we go through, as Nicole and I go through some of these exercises, if you have questions, we have a Q&A section of the webinar that you're welcome to type in a question, and we'll maybe try to address it during the demo. Or if we feel like it's something that's going to be addressed a little bit later on, we'll also try to get to it as we go through this process. So feel free to chat, feel free to post questions, and we'll try to keep this fun and lively. So this is kind of a starting point of the data set. We know that in a real world workflow, sometimes projects will start with some base geometry being modeled in Revit already. I think one of the things we don't necessarily always advocate for is that everything, in this kind of Rhino to Revit paradigm, well, we're just going to model everything in Rhino and then bring it over. More often than not, you're going to have Revit models already set up. There's going to be teams working in the Revit world, and you'll have things like grids and levels and roofs and walls, more conventional building information model elements being created here. And so we have this kind of scenario here where we have a couple of starting objects already set up in Revit, as if the team has maybe located the project and started to rough out certain elements here. We also have a Rhino model. And this Rhino model is thought of as a place where maybe more specialized objects would be created by the design team. You might have a design team for this particular arena developing things like the stadium bowl geometry, using a variety of different tools, maybe testing seat arrangements in rapid fashion, or developing kind of more, complex specialized structure for these long span roofs. And certainly a really popular reason why people like to use Rhino and I think Grasshopper as an adjacent tool is the ability to kind of create freeform complex geometry. So what you see here is a mesh-based exterior skin that's been created that exemplifies something that might be more easily achieved in a place like Rhino, but still needs this sort of pathway to get over into Revit. Oftentimes we receive models that look something like this. When people model in Rhino, it's kind of very up to the author in a way. It's so freeform. Oftentimes it can be very unstructured in its composition. You might have an arbitrary layer structure that you're working with to keep objects organized. And people will model objects the way they kind of see fit. And in other cases, we also will get models that have everything combined into one Rhino model, like what you're seeing on screen here. And this can be great if you're maybe a single author of a Rhino file and you're managing everything together. One of the things we like to kind of challenge or I highlight as an opportunity when it comes to Rhino modeling is that a Rhino modeling experience can also be collaborative, and it can involve multiple participants authoring the Rhino file and environment. And so what we tend to do, especially when we're dealing with a larger model like this is getting close to 400 megabytes in size when it's all together, is to look at some of Rhino's collaborative capabilities and break things down into what are called work sessions. And so this is how the model looks when it's all together. What I'm going to go ahead and do is go ahead and start up a new file here. And I'm going to kind of create a work session environment, which is similar if you've used CAD in the past. You have this ability to do X references between document sheets. Work sessions are very similar in the Rhino world in the sense that you can link in multiple. I've got my stuff over on the screen here. You can link in multiple models and attach them into a model and bring them together. So what we've done is for this data set is we've created this idea of a work session that can combine a number of these elements together. And I'm just going to go ahead and select a few of them here and go ahead and open them up. And what it's going to do is it's going to basically link in these objects. And when I have them linked in like this, you can see that they're, the model's all brought together. These are being referenced now into this environment. and kind of see this nested layer structure off to the side that shows me my individual links. But this now as a means of collaboration in Rhino means that I can say, hey, maybe my structural team or someone responsible for the structure can model their structural objects independently of me. And maybe we have a bowl designer that's working on the bowl objects, or someone that's working on the court and some of these specialty objects here, someone working on the facade. It allows us to kind of break down and create the collaborative experience with Rhino, which has an immense amount of benefit to then the interoperability context, because we can start to be very deliberate about strategies for bringing over these different systems. So this is something I wanted to introduce and put out there as maybe a general thing to think about as you're composing your workflow from the start using your Rhino objects. And just to do a quick gut check before I get ahead of myself, Nicole, is my audio and share screen coming across okay for you?
It is. Everything looks great. We don't have any questions yet, but I'll let you know if we do.
Great. Excellent. Just wanted to do a gut check. Sometimes I have a habit of getting way ahead of myself and realizing that, oh, I wasn't sharing screen, or so there's some technical issue that I wasn't paying attention to. So thanks for helping there with the gut check on my behalf. Okay, so what I'm going to do now is transition back into Revit here, and we're going to take a look at where the end state is going to be taking us. So this is a model that is the stuff that's in Revit, and if I kind of do a view section here, you can see that there's no, there's no structure, there's no bowl geometry here to have a look at, right? We have basically a place that can receive these elements. What we're going to be working up to is this idea that, hey, we're going to build a model that has all of that Rhino information integrated into one spot within the Revit model. We have our bowl, we have seating, we have kind of custom families that are specialized for arenas. We also have an exterior cladding system that's indicative of that mesh. And what we can do with Conveyor is start to really think about it as a way of managing these imports. So everything that's highlighted here that isn't kind of ghosted into the background, this pink stuff as well as the mesh, is stuff that came from Rhino and now exists in the Revit environment. So let's talk about how we get here. I'm going to go into my 3D view here in Revit, and I'm going to go through a set of steps to start bringing some objects over so we can get a feel for how Conveyor allows for element transfer to occur. And there are a variety of different techniques to support element transfer. And based on your project and based on the needs of your and your requirements of your project, you may choose one pathway or another based on kind of convenience or ease or usability. But to kind of set the lay of the land here, if we go to the Proving Ground tab, you'll have Conveyor installed, and you'll have this Conveyor Toolbar here. And here you can kind of get access to tutorials, figuring out what's new. There's a sort of help section. There's what's called the Conveyor Importer, which allows you to bring in external Revit geometry. And then we also have a Rhino.inside integration, which allows for you to use the Rhino user interface and click and send objects back and forth. So we have these different modes of working. And then there are a couple of utilities here that you can use to support material overrides, or exporting some setup files, or even importing some raw geometry. We're going to be focused mostly on Conveyor Importer and the Rhino.inside functions. So maybe to get things going here, I'm going to click on the Conveyor Importer, and I'm going to demonstrate this idea of what it looks like to bring in an external Rhino file first. And what I'm going to do is maybe bring in one section of the bowl through this method, and then I'm going to bring in the remaining sections through Rhino.inside, just so we can get a feel of the compare and contrast here. So what the Conveyor Importer is it's a user interface that you can dock in Revit, can sit alongside your other windows, such as the Properties Manager or the Project Browser. And what this allows us to do is we can set a file location to an external Rhino file. So I'm going to go ahead and navigate to a stadium bowl that I have set up here. And I'm going to go ahead and navigate to the, let's see, learning, models, and start. I'll talk about kind of how this got set up here in a second, but I just want to show the connection in. So this is reading in a file that has a number of stadium bowl sections. You can see that they've been classified as floors. We'll talk about classification in just a second. But it's made this external connection in, and now I can choose which portion of the bowl I want to bring in. So I'm going to go ahead and...
Should we be seeing your Rhino screen?
No, you should be seeing Revit.
Okay, just checking.
Yep. So you can, an external connection was made, and I'm going to go ahead and just import one of these sections. And then I'm going to open up the Rhino file, and we're going to do some other stuff. But I want to get through this first. So a couple of preset sections. I'm going to go ahead and load in these first three. And it's going to give me a prompt to load these elements in. And it's going to bring in a couple of these objects set out as and classified as floors. And we now have some of that external geometry being referenced in. You can see that certain attributes such as the kind of materials have been brought in. If I hover over, these objects are classified as floors. So if you kind of cut a section, by way of demonstration, I'll jump into this section here. You'll have the floor line styles assigned to them. And this, starts to begin to tell that story of, okay, I have information in Rhino, and there are these then pathways that can get these elements into a valuable way into Revit. So
we do have a question about the material import.
Yep, I'll be getting to that shortly. So what I'm going to do is talk a little bit about how this was made possible. I'm going to talk about how this was set up in Rhino. I'm going to talk a little bit about the material assignment. I'm going to talk a bit about the process of classifying an object such that it can come over in this manner. And in order to demonstrate this, what I'm going to do is I'm going to use the Rhino-inside integration to get into Rhino and have a more interactive, collaborative approach with the model. So this is using the Conveyor Importer. I'm going to go ahead and close that down. That's one possible path to look at. Maybe we'll return to that a little bit later as well. But there's also this technology called Rhino-inside. Rhino-inside is a technology that's developed by McNeil, the creators of Rhino, that allows Rhino functionality to kind of run inside of other applications. McNeil publishes a plugin called Rhino-inside Revit, which is focused primarily on Grasshopper and enabling Grasshopper functionality inside of the Revit environment. And what we can do with Conveyor is focus primarily on the Rhino environment. We wanted to kind of create a way for users to take advantage of this integration, but using a user interface that's Rhino driven. So it doesn't require the maybe specialized engagement with the Grasshopper environment. So the way to get things started here is you will start Rhino-inside. So it opens up that plugin. I've already started it in this case, so I don't need to start it again. And then I can open the Rhino user interface. And now this Rhino user interface is sitting on top of Revit. So that means that stuff that's happening here is actually happening within the same kind of memory space on top of the Revit API. And that affords us some really interesting things that we can do with Conveyor and some direct integrations. So I'm going to go ahead and open up that bowl file that I was showing earlier. And I'm going to go through this process of talking through how we get things set up. So I'm going to open up this bowl file. So this is an unclassified bowl. There's no kind of concept here that talks directly to Conveyor. It's just geometry that a user has modeled. And you can see that this bowl model is made up of a variety of different elements here. So we have the stadium bowl itself. We have these vomitory entry sections. And what we want to do is we want to set up a pathway for getting this stuff over into the Revit environment. So the first thing I'm going to do when I'm in this environment is I'm going to do a conveyor V3 command. And because I'm working in imperial units, I'm going to choose the imperial setting. And that's going to open up this conveyor interface. And so this is a Rhino plugin that operates within Rhino and then will communicate to Revit from this setup here. And the way that that happens is that first I need to go through a process of classifying my objects. So this is raw geometry. If I go to my layer manager, you can see that I have a set of baseline layers here. There are materials that are assigned to the different layers. And if I click on my object properties, you can see that we also have object-based materials on top of this. And this is important because what Conveyor will do is it'll attempt to find matching material names that exist between these two environments in order to match materials when things are imported. So that's kind of how the material side works. So there's, we have a number of kind of, I think, more specific tutorials that address that particular topic. But I think at this point, it's important to note that there are materials in play here and that there are kind of materials being mapped across these environments. So this object is a riser, and typically what we see in the world of stadiums is that risers sometimes are classified as floors, and floors require, we want to have the right kind of element category assigned to these. So this obviously isn't like a typical floor type or a floor object where it's kind of planar and has boundary curves. It's much more complex than that. What we can do with Conveyor is say, okay, I want this set of risers here to be related to the floors layer. And it's going to auto assign that floors category. And then what I can do is go through the process of saying, okay, I'm going to click on my object. I'm going to expand Rhino-Revit Direct, that toolbar there. And there are a couple of commands that are exposed. There's get from Revit. We'll talk about that here shortly. But here in this case, we want to just do a send to Revit. And with that object selected, I can do send to Revit. And it's going to go through the process of translating this object as a floor classified element. It's important to note that because this is an unconventional floor, it's brought in as a kind of a direct shape in this case, which is akin to kind of almost doing like an in-place object that's been classified as a floor. They're very, very similar. Unfortunately, with direct shapes, there's not much, and because this is a kind of a complex floor, there's not much that we can do afterwards. We still have to kind of edit things in Rhino and bring it over when it's this kind of more specialized object. When it comes to other types of floors, like kind of planar floors, like the one down here, that have like boundary curves and such like that, those objects can be supported through Conveyor and can be edited after the fact. But just to kind of move things along here, I'm going to do the upper riser here as well. I'm going to go ahead and classify that as a floor object as well, and I'm going to send that over. So while this is coming over, I do see a question in the chat with the stadium riser geometry. Is it best practice to bring it in as a single complex object or over multiple simpler shapes? That is going to very much depend on how you might want to schedule your objects or what you hope the outcome to be inside of Revit. In this case, we have deliberately chosen to keep the riser sections as separate objects. One could set up something where you're bringing over all three sections at once as one object, and that might improve speed, that might improve the manageability of one object over many. And based on your documentation need, that might be perfectly acceptable to your workflow. So when it comes to model breakdown and how you structure things, one of the things we always like to emphasize in this, in these first early imports is the process of understanding what you want your modeling outcomes to be like, and what you hope to have as an end product here? So my answer there is that it depends. And you'll hear a lot of that as we go through here. It's like, oh, it depends. So now that we've got this set up, what I want to do is kind of conclude this portion of the section by just bringing over some of these, they're called VOMs, vomitories. They're like specialized wall objects that might be used for exiting of the risers. So I'm going to go ahead and process those. And while they process, this will be a good transition point where we go over to Nicole, who will talk about different ways with which families can be brought over. There's a lot of nuance there. So I'm going to go ahead and select my VEM walls, and I'm going to assign these to the walls category. So you can see that we have a variety of different objects there selected, and they've now been classified as walls. And I'm going to go ahead and click Send to Revit. And what this is going to do, these are all individual kind of wall objects, and they're all kind of specialized, right? They're all kind of like, they're not just straightforward extrusions, which I think is the key part here. And these also have some materials assigned to them, which is kind of a good way to continue that line of dialogue. So this is now going to go through a process of going through a much larger data set. So you can see that there are a number of different processes that are occurring. And these, as solid specialized walls, are also coming over as direct shapes. Now, as you build up these models and build up the kind of object types that we're talking about here, you might want to, as a manager of the model, understand what's imported and what is non-native to Revit. And what you can do, because Conveyor has these parameters that are assigned to imported objects, we can easily schedule all of the objects that have been brought in from elsewhere and do something like this, which is a view graphics override filter that gives us an indication of, okay, where are all my Conveyor imports and where are the non-imports? So we can kind of get at a glance a view of this. And the data set is also building up a schedule of all imports as well. So this schedule gives us an indication of where all the imports are coming from, last time they were updated, the layer they came from, and their unique Rhino ID. So you can always sort of track things back to their original source information. So I'm going to pass the mic at this point. Now that we've gone through a couple of imports, we got a good lay of the land. We're going to talk in detail about families and the pros and cons of managing families in this environment.
Great. Before I jump into this, there's a couple of questions in the chat. I don't know if you want to address those now or if we want to wrap those later.
I think continue, and what I might do is type answers into the Q&A box regarding these. And if there is anything that comes up in particular about what you're talking about, we can come back to them.
Sounds good.
Awesome.
All right. So we're going to talk about seats in the context of the different ways in which you can bring in objects into Revit and the advantages that each of these ways might have depending on what you're attempting to do. It's particularly powerful for me to think about seats as a former arena designer. My old workflow of getting seats into Revit was drawing line-based families on each riser of the bowl and mirroring that around as applicable. So as you can imagine, that takes quite a long time. And this method is so much faster. So the first way that we're going to bring these across is similar to what Nate was showing. Again, we're using the Conveyor Importer with Rhino.inside Revit. So we'll assign these seats as component families, and we can set them as furniture. And then within this drop-down menu under settings, we have a couple of options. I'll expand this so we can see what we're doing here. We have the option under family import to either use families or direct shapes. So we'll walk through each of those and you can see what's going on. So we'll start with using them as families and send to Revit. You'll start to see the seats populate over. I'm going to bring over my progress bar so you can see what's happening. And this method does take a little while because what it's doing is it's creating a new Revit family for each of these individual seats as their own not just instance, but as their own family. So here we are, and I will show you in the family browser what this means. So for each seat, you can see that it's created its own family, and it's using the GUID or GUID from the Rhino object to name those families. So these are schedulable, and there are some advantages to doing it this way. But if I wanted to wholesale change out these families for another type of family to get to more detail, that would be more difficult than in a method that we'll show you here in a moment. So now let's take a look at what happens if you use direct shapes. And we'll do that with the second row here. So we'll switch in the menu to using direct shapes. Again, we'll do component families and furniture and center Revit. So you can see them populating in much faster because it's not creating families for these individual seats. And then when I go to check these out in my browser, these are really coming in as if they've been individually modeled in place. So they have the attributes of something that you would have modeled in place. The third method is to actually bring these in as blocks. So we've created a block definition for the third row of seats here just to demonstrate what would happen. And each of these is a different block instance of the same block definition. So they're related to each other within Rhino. We can set these again as component families, furniture. And then actually, I'm not sure if this family import line applies to a block, but for the sake of the argument, I'll set it to families and we'll send these to Revit once again. This method is going to ask you if you want to, this seat is the name of the block definition, so if you want to load this, and it's going to create a family, a single family, so it's much faster than creating 20 different families like we did in this first row. And now we have the family seat that was created from the block definition of seat. So this is pretty cool because what you can do then is we've modeled this really simple representation of a seat to make this file much lighter, but you can swap it out then for a more detailed seat. What you need to do in order to get this to work is actually use this seat to build and create a new family. So what we've done is added this more detailed information into a copied version of the seat family that we initially created. That way it has all of the same properties and location point as the original seat file. And then there's, other fun things that you can do with this seat and adding in properties. So for example, you could test out what it would look like to have a person seated. And then you could swap out all of these by selecting all visible in view and changing to detailed seat. So this method is pretty advantageous for something like a furniture import. And I could imagine this being used for a lot of other types of building elements.
That's a great overview, Nicole. I think this particular exercise is an example of how there are more ways than just one to kind of accomplish a goal. And I think it's up to the kind of user to determine what is going to be the most suitable for their particular project. and maybe even in the phase of the project that they're in. Because I could envision that if you're in like a concept or schematic design phase that has a requirement to have, maybe some seats represented in the Revit bowl, then maybe you just use the direct shape method because it's just fast and there's lower overhead. You click the object and you send it over and it will kind of generate the in place representation. But if you know that, hey, I'm going to need to be able to swap out these seats for more detailed ones, and I want to have the ability to evolve the model, then this idea of constructing a block, transferring over the block, and doing a true family type and instance conversion will be the most advantageous, because you can, as you demonstrated here very clearly, swapped out the kind of more conceptual seat for a more detailed seat that might be useful in downstream stages. And I think that's going to be a theme as we continue to go through some of these other examples. It's like, what do you, as a user of these tools, what do you want to get out of it as your end goal for end deliverable? That's going to drive a lot of your selection, I guess, of the workflow. Before we transition over, there were a couple of questions that came up that I think will be addressed in the next section. There is kind of an interesting one here regarding, do you see a future with which direct shapes are editable within Revit? You're going to have to ask the Revit team that question. I wish that were a thing. It would certainly make our lives easier and make the lives of our users easier, for sure. I think I think as you showed here, Nicole, you've already addressed the idea of seats and instances. When you create families, what is the base point for the geometry or the centroid? That is up to you to define. Like when you create a block, and maybe Nicole, you can zoom into one of your block instances there.
Or we could even create a new one.
Sure.
Just to demonstrate. So I just have a poly surface, a closed poly surface selected, and we can block it, and then we can set a base point. So it can really be anywhere. But I've selected this corner of the seat. And then that way we can create those other more detailed families using the same seat corner. You could set that to be a base point that's hitting on the actual riser below, or you could set it to the center of the seat. I think that was the question, but you get to determine that. There's not really a default preset for that. So now this is a block, and I could instantiate it as many places as I want and then bring that in. And because I've named it differently than this other block, those would be two independent things. So that might be useful if you could imagine you'd have different types of seats.
Two other questions that came through. One is, are nested Rhino blocks supported through the importer families? At this point, no. It's assuming that the geometry contained within one block, it won't go down another block level of nesting. That's something that we're, I think, planning on introducing as a next set of features for sure. That's something that's come up a few times in terms of a user request. So great idea. We hope to kind of continue to evolve that portion of the integration for sure. Once, this is something that comes up quite a bit. Once you've transferred information such as families into Revit, is there an active link back, meaning that if you change something in Revit, you're able to push the changes back into Rhino? Not exactly. You are able to bring, and maybe I can start off the next section here with this. You can bring Revit geometry back into Rhino, but it's not going to necessarily affect the original element. So that feedback loop is one, extremely tricky to pull off effectively. Yes, it can. You kind of the information is being transformed as you're jumping from one environment to another, and the way that objects are handled in one environment are tricky. So going to Revit and then back into Rhino and have there be a kind of consistent way of maintaining a reference link is it's possible in some scenarios. In other cases, it might break down. So there is an aspect here where when it comes to managing your project, you want to understand the flow. You want to kind of understand, where is the work happening? How are you managing the work in one environment? And then where are you as a project team making the jump into Revit and so on and so forth. There's sort of a bit of a deliberateness to doing it because it's not going to solve all possible integrations. It'll ease integration, I guess. So I'm going to go ahead and jump back over to my screen and continue with maybe some of those thoughts in some ways. So I'm going to go ahead and jump over, share my screen. So we're back to this model, and I'm going to go ahead and go back into 3D view here. And I'm going to open back up my Rhino interface. So this is kind of where we left things off with the bowl. And the idea so far is that we've been able to bring over geometry for the bowl, and we're using a direct shape method to accomplish this. Nicole covered different ways with which maybe component families and those types of objects, kind of more componentized architectural elements like seats, may be brought over a variety of different ways. I'm going to kind of jump into how one brings stuff back over into Rhino, and you might need things for reference because model coordination is extremely important in this context, right? You want to be able to ensure that your models are kind of aligned and located properly, and that you're using an appropriate amount of reference geometry to develop Rhino models. And so that's where this get from Revit feature comes in. We can zoom out here in Rhino or in Revit. Always get my wires crossed sometimes when we're talking about two programs that start with the letter R. I'm going to go ahead and turn off this section box here. Now I'll keep it open. That's fine. What we might want to bring over as an idea for reference over into Rhino is maybe we want to reference things like grid lines. And grid lines to locate our Rhino model relative to Revit. Grid line, grid set might be established in the Revit world first, and then you want to have something that you might want to locate your Rhino model against. So I'm going to go ahead and just select a few of those grid lines. And inside of Rhino here, I'm going to choose the Get from Revit feature. And what this is going to do is it's going to draw those grid lines now represented as Rhino curves. So we now have these as a way to kind of see where objects are lining up. So if I wanted to continue, maybe I wanted to kind of design some columns or some other components inside of the Rhino environment, or maybe I need to locate a particular set of Rhino geometry against these grid lines. This feature allows me to start to, coordinate that back and find some of the key organizational datums to work with. We can also do the same with objects like floors and walls. We've got a couple of floors here inside of the Revit environment, and you can select on those and say, okay, let's get those over into the Rhino environment as well. And that will then create those floor objects. So we can start to kind of mirror these over back into Rhino as reference points. We can, maybe you need to bring Revit geometry over into Rhino for, again, the coordination exercise, ensuring your bowl's lining up with everything as you're designing it here. Maybe you need to bring over this information for visualization. Maybe you need to bring over your walls and doors and things like that that have been modeled inside of Revit. And so you can render things in Rhino, because maybe people like to use Rhino for their rendering solution. So a number of integration opportunities there to be aware of, and things that can just help stitch together these models a little bit more closely. One of the things that we've encountered as a question quite a bit is this idea of like, well, what happens, how does the Rhino model need to be oriented in Revit? And we are using the project origin as the relationship between these two things, such that, it's not going to use a site point location. It's going to be using the kind of Revit origin point as a way to kind of base where things are coming over. So that's an important thing to know. And you might need to relocate your Rhino model relative to kind of the Revit setup in order for the integration to occur in a more seamless, streamlined way. So I'm going to jump into another set of elements. I'm going to get into some of the structural objects that we have set up here. And one thing that you can do in the context of this, I kind of highlighted work sessions earlier. I'm going to go ahead and open up a work session manager. And I'm going to go ahead and attach my structural object, my structural objects here. So I have a structures reference that I'm bringing in. And what I can do is set my structure to be the active model. So right now I'm still working in the bowl, but now maybe I want to start working with some of these structural objects here. So I'm going to go ahead and select my structure and I'm going to say, make this the active one. I'm going to make sure I save my changes to the bowl. And the work session is going to basically invert my layer structure and bring the structural elements to the front. And now I can start to pick and choose and build up a conveyor workflow using these structural objects instead. And I think this is really important because another question that we often get is, well, can I be working with multiple Rhino models in the conveyor workflow? Should I only ever have one model, or can I be working with multiple? And the answer is you can work with multiple. We can still track updates across multiple objects. If I click on one of my imported floors here, you can see the file path that it came from. So this came from the bowl Rhino path, and our schedule would show that as well. And now this one will come from the structure file path. So in this case, what I'm going to do is make sure I have my conveyor setup complete. I need to open my Rhino window a little bit more. So this is going to activate the conveyor setup here. We need to make sure that, when you're in a model, that this conveyor layer structure is active, which is how this interface, assigns meaning in certain object conditions. So I'm going to go ahead and click on the selection of objects here. These are kind of more specialized long span roof structures, right? And I'm going to go ahead and make these structural framing. So this is going to bring the objects over as a kind of framing classified object. And because this is a unique shape that's been defined, it's a unique solid shape, it's also going to use this is going to be another instance where that direct shape translation is going to occur. I'm then going to show you the way of doing kind of more native structural framing using line-based. But for right now, what I'm going to do is go ahead and select, again, these objects. Should not have deselected before. And I'm going to bring these over wholesale back into Revit. And what we should see are a couple of these trusses being brought in. And because I have my section box on, I need to make that a little bit more generous here in terms of what we're showing. Yeah, there we go. So there we go. So there's the imported object, and it's classified as a structural framing element. Now, there's another pathway that you can take when it comes to bringing your structure over. And again, this all depends on maybe the phase of the project that you're in or the requirements for your documentation. In this case, what I might want to do is choose to bring in more of a native structural framing element with a type onto it. So you'll see that inside of this data set, the structural data set, we have both a solid structure, we have a structural grid, I'll turn that off. We also have these structural center lines. So if I turn off the solid structure, you'll see that there are these center line objects. And structural framing is a line-based kind of family. And the way it works is that when you're modeling this stuff natively in the Revit environment, you are like drawing a line and you're assigning a type to it. The same kind of philosophy can apply here, wherein you might have a set of curves like so. I'm going to kind of select this run of of objects. And what you can do is say, okay, I want this to be structural framing, and I want this to be a particular size of beam. So one thing that we need to do is we need to make sure that we have an appropriate size to map to. I'm just going to jump over into the structural framing member sizes here that we have loaded into this project. So we have some W shapes and we have a 12 by 26. And what I've done is I've selected those centerline curves and I've selected W shape 12 by 26. So if I zoom out here, I want to make sure I don't need to save the project at the moment. We'll see where these pop in. So I'm not sure if it'll come in on the left or the right. I'm disoriented right now in terms of the orientation of my project. Let me go ahead and click send to Revit. And what this is going to do is go through the process of finding those center lines and drawing the structural framing in. So you can see that there's the structural framing that's popped in. And what's nice about this is that if I click on the, so this kind of specialized solid structure, we can't really do much with it after the fact. It's great. It cuts. It will be a valid representation of the three-dimensional geometry. This particular object using line-based structural framing families now has a type that I can change and edit its properties on. So depending on your need here, you can start to map your structural framing types across the Rhino and Revit environments using this particular methodology. Let's see a question in here. Is that reading your W shapes located in the Revit on type in Conveyor? So yes. The way that Conveyor sets up over in the Conveyor interface is that when you launch Conveyor through Rhino.inside, Conveyor is going to suck in your available types and have them available as there's some default ones, and then there's ones that kind of come in from your current active Revit project. And then you can create other ones if you need to map them over for sure. I'm going to kind of try to round out the exercise a little bit more as well, because there are some specialized elements here. Just want to make sure we've got some questions. Oh, there are a variety of questions here. Let's see. Can we point Conveyor to a folder to load families if not yet loaded into the Revit project? At this point, no, it won't. There's not a kind of an auto load of families. That's an interesting feature that maybe we can kind of consider mapping out if there's like, a way to preload. I think that might even come in really handy with adaptive components or such. The tricky bit is, the way with which you assign things in Rhino is so open-ended. We'd have to weigh flexibility versus how regimented we would get with something like that. That could be kind of interesting. Can you adjust the rotation of the structural framing section through Conveyor? Great question. We do have, and this is, we do have some Grasshopper based components that allow for that rotation value to be entered in. We haven't quite found an elegant way of accomplishing it just in the Rhino out of the box interface. It might require us to introduce kind of some exposed properties, some additional property editing in this interface. So it is possible, but it's possible more through the Grasshopper side. And I guess there might even be an interesting workaround where if you edit the user text on an object, Conveyor will pick up, if you create a bit of user text on the object that's called rotation, and then you give it a numerical input, that may also pick it up as well. We might explore that workflow a little bit more in a future session or a tutorial. I think that's an interesting question. So I'm going to kind of get into some of the other kind of components here to round it out. I think I'm going to skip maybe the court since we're low on time, but I did want to show the facade because I do think the facade is really interesting, adds an interesting dimension to all of this as well when it comes to meshes. So this will be a quick demonstrator if you're willing to sit tight for another minute or two on the session because we're right at the hour. But the facade is an example of one of Conveyor's more novel translation capabilities. On some of the projects I highlighted early on in the session relative to the Lucas Museum, the Gilder Center by Studio Gang, there was a lot of kind of attention to meshes as an important kind of piece to have represented in the Revit model. And when you bring a mesh over using a more conventional, like export a DWG or a DXF, and then you import it in to Revit, you end up with all the triangulation, and it's not useful for anything other than maybe some level of clash detection or general coordination. It doesn't look good in your documentation. Conveyor introduces some rather novel mesh processing in that we can take a mesh like this and assign it to a category and use the Conveyor's mesh processing to hide mesh faces from view in Revit, which can allow for some rather clean representations of meshes that can look good in a document set, for example. So what I'm going to do is I'm going to go ahead and assign this mesh to a component family category. I'll just make it generic model for this time being. And I'm going to go ahead and send that over to Revit. And it's a more of a sizable mesh. So what's happening behind the scenes is that we're basically doing some mesh post-processing before it's brought in to the Revit environment. It's going through a process of hiding mesh faces that kind of fall within a certain angle tolerance. And then it'll also ensure that edges that are kind of more on a crease are visible as well. So it's attempting to create a mesh that will appear good in the Revit environment. And this type of workflow is really useful on maybe extremely complex facades, like what we're showing here, where there's kind of a high amount of complexity to the geometry that's not as easily perhaps represented through NURBS. It's also very useful for landscape purposes. And it's also useful for like high resolution mesh scans of existing conditions. And what I'm going to do at the conclusion here is show you where you can find some additional resources on some of these workflows. We have seen people really take the mesh thing to an extreme where the majority of their projects are mesh based just so they have something in Revit. We don't necessarily recommend that. It's a lot of the approach that you take here and the workflows that you select are going to be based again on what you feel is going to be the best approach for your particular project. And so here you see this is what that mesh looks like after it's been brought in. And if I go to the conveyor import view, we can see now the current state of the model. We can see that we've created that filter that finds imported objects and kind of half tones the existing Revit objects in as well. So where to get more information about Conveyor? We have a website, apps.provingground.io. This is where you can download and try Conveyor. This is a commercial tool. So it's not a free tool. Like Rhino-inside Revit is a free tool, and it's a very powerful free tool that we've integrated on top of, but we've also introduced a lot of functionality that cuts out what we feel a lot of waste in the modeling process and allows for far more simplified workflows and user interfaces that can appeal to a wider audience. So we do have licensing options here. We have a perpetual license that you can download for the current version of Conveyor. We also have some enterprise options as well if you're looking to scale Conveyor use in your organization. But if you're interested in learning more about Conveyor, we also have a rather extensive documentation portal that you can search. So if you're wondering, like, how do I convert a curtain system? We can, search our documentation and we'll find a variety of different capabilities for handling the import of a curtain system. And we try to supplement a lot of this documentation with imagery, step-by-step, and those kinds of things to get you to your goal. We also have a variety of different video tutorials available that will step you through kind of an essential workflow guide. We have, new features. So if you're just getting onto V3, maybe you've been on V1 for a while, you want to get oriented towards what the new workflows are in version 3, you can learn about those. And we've also, and this is where you'll be able to find the documentation set in the aftermath of this workshop. Go to our examples and samples section. And what we're doing here is we're providing example Rhino models that you can use to test conveyor out, that have a variety of different workflow types, samples, materials, classification styles, things like that, that will allow you to move and try out some imports here. This one's a pretty popular one, just because it has a lot of family-based options in here, kind of the conversion of stairs, for example. This one shows a variety of different wall options, curtain walls, kind of more massing-based walls, wall by face, standard extruded walls. And we also have some pretty fun mesh examples here that take high resolution meshes and allow you to bring those over using the mesh import capabilities. So this gives you an idea of some of the things you might need to have in Revit as context. We were part of a pretty interesting project not too long ago that involved a lot of rock work. And so meshes became really kind of useful for handling that kind of element type. How are we doing on questions, Nicole? Have you seen anything pop up that maybe we should address before we?
There have been a couple. One is that we mentioned there would be a recording of the training available, and you pointed out where those things live on our documentation, but will we be emailing out a link to any of those?
Absolutely. Great question. So since you're obviously attending the webinar, you're on the email list for a follow-up email that we'll send out likely at the end of the business day today, that will point you to the recording of the session, as well as the associated files we explored. So you can expect an email directly from me that will point you to the recorded video on YouTube. Let's see.
There is a question. Oh, yeah, go ahead.
Go ahead, Nicole.
I was curious about Kyle's question. If the dimensions are assigned to an imported block family and those families are updated in Rhino, do the dimensions stay attached in Revit? I actually don't know the answer to that.
The answer to that is it depends on what kind of object and what kind of update you've performed. If you've kind of performed a wholesale update to the family, it very well may need to create a new family to keep it in alignment with Rhino, in which case attached dimensions will drop off. If you have made a modest update to a family, maybe you've changed the family's location in space, or you've added to the geometry in some way, then dimensions may be retained because it's maintaining the same element ID. There is nuance to what level of change requires a new element to be created inside of Revit and Rhino. And I think part of feeling that out is, comes from just gaining experience with the software. Oh, I do see a question here about version updates and licensing. So what we typically do is you buy a perpetual license. It's perpetual, meaning that it's, it's not subscription based. So if there's a version update, typically what we offer to people that have owned past versions of Conveyor is that they will get a discount on upgrading to a new version. So if you're a perpetual license owner, you can have a look at your user account on the Conveyor website. We do have a user account management portal, and we have that documented here. So there is, there may very well may be upgrade paths for you. If you log in, check out your purchases, and then check to see if there are any upgrades that are available that would allow you to upgrade at a discounted rate.
There's some curiosity about the grasshopper functionality. Do we want to quickly show just what options are available there?
Sure. I will maybe highlight a follow-up to the question that was just asked. Do you provide a subscription-based license? And the answer to that is, to a degree, in our enterprise setups, if we are working with a company that has multiple licenses being managed, like a couple of our an example is we work with Perkins and Will on kind of an enterprise setup of this stuff. And because they're on an enterprise setup, they get access to all the versions of Conveyor with kind of a support agreement as well. So that's something that is certainly available, and we can talk about relative to your organization. I'm sorry, Nicole, what was your?
Oh, it was about Grasshopper. I can quickly borrow the screen just to show the interface.
Sure, go for it.
So here in Grasshopper, sorry, it's hidden under my Zoom tab. There's a Proving Ground tab that should show up if you have Conveyor installed. And then there's a full panel here of all of the different functions that you can use with Conveyor inside of Grasshopper.
I will highlight as well, one of the design considerations here with the Grasshopper tools is that we wanted to create some rather, I guess, simple self-contained operations relative to element types that people are oftentimes transferring over. These components do have outputs that connect into the Rhino-inside Revit toolbar as well. So if you pop over to the Rhino-inside Revit toolbar, it's Revit. Revit is what it's called.
Gotcha.
There's a massive toolkit here for Revit support. Even for me as an experienced Grasshopper user, I find it extremely overwhelming. And so part of the reason why we've created a more limited kind of set is we've found stuff that we consistently reach for in our workflows to make the integration option for simply sending things over more straightforward. So yeah, the idea is that they can also serve to enhance and counterbalance each other in the overall Grasshopper workflow if Grasshopper is something you're using, which isn't, again, a prerequisite for using Conveyor. A lot of our emphasis is on the kind of more straightforward Rhino modeler.
I'm looking to see if there are additional questions. Esther's asking, how do we modify a floor from Rhino into Revit? So I think we had touched on it earlier, but if it's a more simple floor, just a flat floor with a boundary curve definition, then you can modify that once it's been imported. But if it's a more complex floor, then you can modify it in Rhino and then bring it back.
Yes, absolutely. And what I'm going to do is kind of maybe just use this as a chance to reiterate the documentation here. So converting a floor, there are a number of ways of doing it. We can do it as a floor with a Revit type. There's a floor as a solid direct shape, and so on. And so if you were to set up a floor like this, wherein your Rhino model is, dealing with planar floors, this piece of documentation will highlight how you can achieve the translation of that floor. So this is a floor with an opening. We can assign that to a floor type. Conveyor's Importer, as well as the Rhino-inside integration, will allow for floors with types to be created and also editable after the fact. So if you were to double click on the floor, you get the boundary curves and things like that. I know that we're 15 minutes over. I wanted to just say thank you for attending. I hope you found this useful and informative. And hopefully, if you're an existing user of Conveyor, thank you for supporting the product. We hope that this was insightful and useful. If you're looking for different integration opportunities and think that this might fit the bill, give Conveyor a try. Feel free to reach out. We'll do our best to answer your questions. And be sure to check out the documentation. We kind of believe that a lot of the, what kind of goes into making a product valuable is ensuring that we have the workflows adequately captured and can help guide a user through the experience and obviously the complexities of a piece of software. So hopefully this is all valuable to you in the aftermath of this session. But stay tuned for the workshop recording, and we look forward to hearing from you soon.
Thanks, everybody.